Hey, what's up everybody? This is the Helpful Hacker, and today we are going to be going over the Tcpdump The Basics room from TryHackMe. So we'll jump right in and get started with task number 1, the introduction. So basically, Tcpdump, it's a command line tool that is used to capture, filter, and display packets. So it's used for packet analysis. So make sure you read all this. It'll tell you a little bit about it, and this also mentions the libpcap library, which is the library that was used to create Tcpdump, or one of the libraries. And basically, they bring this up because this library is the foundation for lots of other networking tools as well. And then they let you know that that was also ported to Microsoft Windows as WinPcap. And so basically, these are important libraries. They're really good for networking tools that involve packet analysis or capture, and you should recognize them. So keep that in mind. Down here we have our learning objectives. Like I said, Tcpdump is all about capturing, displaying, and filtering packets. So that's really what we're going to learn in this room. Then the room prereqs are all networking rooms. So if you haven't done all these rooms, I suggest you do. You can find full walkthroughs of each one of these rooms on my channel, so check that out there. But yeah, in order to use Tcpdump, you're going to want to have some basic networking knowledge, and these rooms will give you that knowledge. So with that, you can start your machine, and then let me minimize that, and then we'll get down to the questions. So what is the name of the library that is associated with Tcpdump? So that would be this libpcap library. That last one. So submit that, and then with that you are done with task number 1. Now it's on to task number 2, basic packet capture. So here they kind of do this in a funky order. So first I'm going to talk about network interfaces. So on a computer you can have you pretty much always have multiple network interfaces if you include the loopback address. Sometimes you can have lots of them, sometimes you don't have that many. But basically when you're trying to capture packets, you need to decide what network interface you're going to be listening on. And let's say you don't know what your network interface is. How do you find it? You find it by typing in IP address show, or you can just do IPAS. So if this is loaded, here we go. I'm going to pull this up in full screen so that we can see it better. So if I come over here and I do IPAS, it's going to give me a loopback address and this ENS5 address, right? Or I shouldn't say address, I should say interface. So these are our two interfaces. And that's important because, like I said, you need to pick which interface you want to use when you're using Tcpdump. So that's how you would figure out your own interface right there. And then you would use the command Tcpdump. So once you know all your interfaces, you type in Tcpdump, and then the first thing that you're always going to want to do if you're capturing packets, so this is specific to packet capture, is do -I. And what that stands for is interface. And you can follow that up with either the interface of your choice. In this example, or down here, they kind of give you this interface, this ENS5, which we can see right here highlighted. So I could pick that interface, or another option is you can just type in any. And what any will do is it will listen on all available interfaces, right? So that's important. So that's kind of the basic usage of Tcpdump. So if you wanted to, you could just type in Tcpdump, pick the interface, and then let the packet capture run. So that's as basic as it gets. Now, the next part, saving packet captures. So if we want to save everything that we've captured, we do -W followed by the file name. And we just provide the file name of whatever we want it to be, and it'll be saved as a PCAP file, which stands for packet capture. Additionally, let's say we don't want to capture packets. Let's say somebody already did that for us, and now we just want to read what they got. That's where we would use the -r argument. And so -r followed by the file name of the previous packet capture will just display it for you. So then you can read through everything. Then we have -c, and this is going to be count. So let's say we only want to capture 20 packets. Then we would do -c followed by the number 20. Or let's say we only want to display 10 packets. So let's say we're reading from a file. We can still use count, and we will only display the first 10 or 5 or however many packets we choose. And then down here at the very end, they give us -n and -nn. And so normally Tcpdump by default, what it's going to try and do is if you have an IP address, it will try and convert that IP address into a domain name. Additionally, if you have a port, which you'll have an IP address and you'll have a port because that's how packet capture works. So I don't know why I'm saying if, because you always will, but if you automatically, what'll happen is Tcpdump will try to convert the IP addresses to domain names, and it will try to convert the port numbers into protocols. Okay, now, and they give us an example with port numbers here. So port number 80, it would change that to HTTP. Now, if we provide the -n argument, it will only use IP addresses. So instead of trying to find the domain name, it'll just be happy using only IP addresses. If we do -nn, then it'll use only IP addresses and only port numbers. So that's what that's for. And they give you an example down here. So Tcpdump, they pick the interface, which is ENS5. They're only going to capture 5 packets because they use the count argument and then -n. So we can see here, all of these are going to be in IP addresses. So we can see the actual IP addresses. And they're not getting converted to any sort of domain names. So that's their example. Make sure you read through all these and kind of understand them. And then down here we have verbose. So -v stands for verbose, and what that does is it's just going to provide additional details. Now there's 3 levels to this. We can do 1V, 2Vs, or 3Vs. The more Vs that you use, the more detail that you're going to get. So if you do all 3, you're going to get the most detail that Tcpdump can provide. If you just use 1, you'll get a little bit of extra detail, and if you use 2, then you'll get quite a bit of detail, but not all of it. So down here they have a nice summary of all of those. So read through this table. And then they want us to take a look at the following examples. So this example, we're picking our interface, -I, and that's ETH0. Then we're going to count 50. So we're only going to capture 50 packets. And we want a little extra detail, which is why we're using verbose. Then this next example, same thing. We have our interface. This is WLO1, so that's our interface. And we want to save this. That's what the -w does. And we're going to save it to a file called data.pcap. So now we'll have that file saved, and we can always access it. Then down here, Tcpdump-I, any -nn. Basically, we're going to listen on all of the network interfaces, and we only want IP addresses in domain and port numbers, nothing else. So we don't want domain names and we don't want protocols. We want IP addresses and port numbers. So that's what that does. Now down to the question, what option can you add to your command to display addresses only in numeric form? That would be -n. So with that, you've answered the question and you are done with task number 2. Now it's on to task number 3, filtering expressions. So down here, although you can run Tcpdump without providing any filtering expressions, this won't be useful. Why? When you run a normal like Tcpdump or any sort of packet capture, what you're going to get is you're going to get a ton of data. Especially if you're not filtering anything, you're just going to get a ton of it. And then it's really hard to go through. So by using filters, what we can do is we can limit how much data we're actually getting. and we can pick up only what's useful to us. So they give us some filtering stuff, and the first one is host IP address or host domain name. So instead of capturing everything on an interface, we could only capture things from example.com, or we could only capture things from a specific IP address. So that's what this host filter does. Okay. And another note that they give you down here is you do have to be logged in as root to use, or you have to use sudo to run a tcpdump capture. So what sudo does is it just makes whatever comes after it, it makes it run as if you were the root user. So that's why they have this sudo thing. If you don't know too much about it, don't worry about it. It's not really part of this room. But if you don't know what that is, then you should check out the Linux Fundamentals 1, 2, and 3 room on TryHackMe. That'll teach you about this. And I also have full walkthroughs of those, so you can check those out on my channel. But yeah, so they give you that little note, so make sure you read through it. And then down here, they let us know you don't just have to do it by one IP address. You can even get more specific, and you can say, I don't want things to and from this IP address. I only want things from this IP address, or I only want things to this IP address. So we can get even more detailed and say a specific source host name or a destination host name. So that's useful, and that's the case with most filters, is you can additionally filter it by source or destination, which is what we'll see with ports. So the next thing they talk about is ports. So we can filter by port number, and we can also filter by source port and destination port. And they give us a nice example right here. So they're filtering for port 53, which would be all the DNS traffic. So read through the examples, make sure you understand these. And then they also allow you to filter by protocol. And here are some of the supported protocols that you can actually use. So there's that. And that's really helpful, and it's a quick way to just narrow it down. So some examples: UDP, TCP, ICMP. That's what they're going to use down here. They're just going to show us all the ICMP traffic, which is nice because then they don't have to worry about all the other stuff. And then down here, just make sure you read through the example so you kind of understand what they're doing. And then they also talk about logical operators. So you have and, or not. And these are pretty intuitive. So in this example, tcpdump host 11111 and TCP. So what I'm doing is first I'm going to filter by IP address. So I'm only going to take things that have this IP address. But then on top of that, I only want things that have that IP address and are using TCP. So that's how that works. You can get very detailed with this. And then or, again, intuitive. So in this example, I want something that uses UDP or ICMP. So I will capture both of those. And then not is just going to be the opposite. So in this example, TCP or Tcpdump, not TCP, that means I want everything except for TCP. So if a packet's using the TCP protocol, I'll drop it. So hopefully those are pretty intuitive and make some sense. Down here is a nice summary. So you can read through this table, make sure you understand all the different parts. And then they give us some examples. So consider the following examples: tcpdump-I, any TCP, port 22. So I'm filtering by port 22 and TCP protocol, and I'm listening on all of the network interfaces. So basically that's going to be all of the SSH traffic. Next example is same thing. They're picking their interface, and it's going to be WL01, and they want UDP port 123. So now it has to be on UDP, and it has to be on port 123, or it has to use UDP and be on port 123. And that would be the network time protocol is what they're filtering for there. The next example, again, they're selecting their interface, ETH0. The host is example.com, so it has to be coming to or from example.com, but it also has to use TCP port 443. Okay. So, and then they're also at the end here, they're saving it to a file called https.pcap because port 443 is the default for HTTPS traffic. So yeah, and then for the questions from the task, we will read captured packets from the traffic.pcap file as mentioned earlier. Okay, so there's this traffic.pcap file that they're going to use. So here, let me actually show you something real quick. So when I did this room, I started out by just starting this machine. Oh, that's not it. Where is it? Yeah, I started the machine right here. Now, some of you may have preemptively started the attack box. I'm just going to show you what happens if you do that. So if you have both the machine and the attack box open, in split view, you'll see this Tcpdump Basics and this THM attack box. So if you're on the attack box and you want to stay on the attack box, that's why they give you these SSH credentials. They give you these credentials so that if you're on the attack box, you can SSH into this machine, this Tcpdump Basics version 0.1. Now, me, I did not do that. I prefer just to be on the machine. And so this is what it looks like if you're on the machine, right? And this looks different than our normal attack box. And then again, I always like to go full screen, so I have it full screen open here. So keep in mind that if you are on the attack box full screen, then you won't be able to jump between these two machines like I am here. This view is only available on split view. So that's stuff to keep in mind in case you are confused, because here, if I do ls, I see this traffic.pcap, but if you tried to do that on the attack box, it wouldn't show up because you're not on the right machine. So keep that in mind. Hopefully that was helpful if you ran into that problem. So now that we have that squared away, we will get down to the questions. Let me see actually. Did we go through all the examples? Yeah, now we're talking about this PCAP file. So I just wanted to make sure that you were able to find it. So again, here you just ls and you'll see that file right there. And if we remember, in order to read a file of a previously done capture, we have to use the -r with the file name, right? And then another thing that they point out is you can pipe your output to the WC command. And now what does the WC command do? Well, if you don't know what a command is, you should check out the man pages. So if we look at the man pages for WC, we see that it gives us the new line, it gives us the word count, and it gives us the byte count. So that's what happens if we just used word count as is. So in their example right here, they do Tcpdump. They're going to read from our traffic.pcap file that we have to use to answer all the questions. They're filtering for a source host, and the -n, that means that they only want to use IP addresses. They don't want any domain names. And then they pipe that into word count. And the output looks like this. So you just get these three numbers. But because we read the manual pages, we know that the first number is the number of new lines, which would be equivalent to the number of packets. The second number, that's going to be our word count. And then the third number is going to be our byte count. And that's going to be useful, and you'll need it even for this first question. So let's take a look at the first question. How many packets in traffic.pcap use the ICMP protocol? So let's clear this. And let's do Tcpdump. And we're going to do -r for read. And we want traffic. And also, I just hit tab. That's how I autocomplete. So that's why I didn't have to type out the whole file name. And then we want to filter by ICMP. Is that what they said? Let me double check here. What were... Yes, ICMP. So first, I'm just going to run this and see what we get. Okay, so we got quite a bit of stuff, and I don't feel like counting those. So what we can do is if you hit the up arrow, you'll go back to old commands. So let's go back to our old command and then let's pipe it into word count and see what we get, right? So that's a lot easier to process. So now we know we have 26 packets because each packet is one line and the first number is the lines. So we can submit that. Now down to the next question. What is the IP address of the host that asks for the MAC address that ends in .137? So I know, because I know a little bit about networking, that when you're asking for MAC addresses and mapping them to IP addresses, that's the ARP protocol. So I'm going to take a look and see what I get here. Okay, so that's super easy. There's not a whole lot of ARP packets, so I just have the 2, so that's easy to read. Something that I want to point out is if you look, this IP address has dashes between it, right? So if I were to copy and paste that over into TryHackMe, it would tell me that I have the wrong answer. But what I can do is I can do the -n or -nn, either way. And now if I look at it, now it's giving me just normal looking IP addresses, right? So that's why the -n and -nn is useful. So now back to the question, they want to know who was asking for this IP address. So if we read this, this person on this first line is saying who has this IP address, and they want you to tell them. So that means this is their IP address. So we'll just copy that number or that IP address, paste it in there, and that's the correct answer. Now, what host name or subdomain appears in the first DNS query? Okay, so now we want subdomains. So I'm going to get rid of that -nn. And now what some of you might do is you might try and do DNS. And that's not going to work because that is not one of the protocol filters for Tcpdump out of the box anyways. I mean, you could probably make something like that happen if you customized it, but I digress. So instead what we have to do is we have to filter by port, and we can filter by port 53 because that's where DNS happens. And if I do that, there's a bit of traffic, not a whole lot, but it's nice because they just want to know the first DNS query. So I don't have to dig through all this. I can just look at the very first one, and I can see here, this looks like our domain name, and they want the actual subdomain. So I can copy paste that, and with that, we are done with task number 3. Now it's on to task number 4. So this is more advanced filtering. And we can filter by a few things. Here we can filter by using greater or less than and length. And so we can filter by the length of the packet. So once you know a little bit more about networking and packets and all that, then this can become very useful. This can help you find things if you know that there were certain packets that were sent that were very large in size and they have sensitive information on them. You can use something like this to help you filter for those. So those are good filters. And then another thing that they recommend is this PCAP filter manual page. So if you just type in man PCAP filter, it will help you go through and understand, you know, some of the different filters that you can use with Tcpdump. So then down here, they're going to give us an introduction to binary operations. So the way that binary operations work is you have 2 inputs. So binary will take 2 bits and it will do something with them depending on what operator or operation you're using. So we'll talk about the AND operator first. So AND, what it'll do is it will return 1 if both of the bits are 1. So if it's 1 and 1, it'll give you 1. Anything else, it's going to return 0. And this chart is, or this, yeah, I guess this little chart / table thing is helpful. So take a look at that. Then we have the OR operator, and this is done with the pipe. And what this will do is this will give you a 1 if one or the other is 1. So here we can see that all three of these will return 1, and the only time it'll return 0 is if both of them are 0. So one or the other. That's the way to think about these. And then not is just going to do the opposite. So if you supply a 0, it's going to invert it into a 1. If you apply a 1, it'll invert it into a 0. So those operators are useful. Don't feel too overwhelmed if you haven't heard about them or if you don't really understand them. You'll get more practice as you go through TryHackMe. Now, another thing that they're going to talk about is header bytes. So basically, using PCAP filters, Tcpdump allows us to refer to the actual content of any byte in the header. Okay, so if you have a good networking fundamentals, kind of like if you've gone through all the prerequisites for the room, you should know that there are different headers, right, involved with each step of the kind of the networking process, we'll say. And you can actually filter based on the contents of those headers. And that's really useful. And we can do that by doing this right here. And this this stands for the protocol. And then EXPR stands for the byte offset. And the way I like to think about that is that's like, which byte are you starting out with? Like, what byte are you looking at, right? So 0 refers to the first byte. So if I do protocol, let's just do ARP and then 0, then that means I'm looking at the first byte. And then I can follow that with size. And size will give me the number of bytes that actually interest us. So maybe we're only looking at 1 byte and that's all we care about. Or maybe we want to know what's inside a couple of bytes. And depending on both of them, that's how we want to filter, right? And so you can read a little bit about the size right there. So that's kind of this basic format for PCAP filtering or PCAP filters. And then here they give us some examples. And they give you a warning. They're like, hey, if you don't understand this, like, don't sweat it too much, okay? It's pretty advanced stuff. And what we're mostly going to be using is this stuff down here. This is what will be a bit more useful to us. So all of this, I'm still going to kind of go through it. I'm not going to get too detailed because it's just not really relevant to the room, but you should probably have it in the back of your mind. And if you ever get more advanced with tools like Tcpdump or Wireshark, this is the kind of stuff that you would be using. So first example, Ether. Again, we're going to refer back to this syntax. So we have our protocol, and that stands for Ethernet. And then we have this EXPR. So that's our starting point, and it's 0. Now notice there's no size. So that all that means is since there's no size there, we're only looking at 1 byte because it says right here, it is 1 by default. So if you leave that size thing empty, then we're only looking at 1. So we're looking at the very first byte. And then we have this expression. And so what this does is and 1. So it takes the first byte that we started out with in the header, and it takes the decimal number 1, okay, in binary, because this is all binary that we're talking about. And it applies the and binary operator. Now, it will return true if the result of that is not equal to 0. So what it's doing is it's taking this byte, and it's taking the decimal 1, and it's performing the AND operator, which we talked about up here, right? So again, lots of binary. It's okay if this is a little confusing. And it's saying, if I do this, right, if I take that first byte and I do the AND operator with, the decimal number 1, and if that is not equal to 0, then that's what I want. That's what I want to pick up. Now, if it is equal to 0, then I don't want to pick it up. So hopefully that makes a little bit of sense. Again, this is kind of tricky stuff. I'm trying to explain it the best that I can, but once you start getting into binary, it requires a bit more effort to, really dig into the example. So hopefully that helped. And then same thing here. We're going to do the exact same thing pretty much. So now we're using the IP protocol. So the IP header is what we're looking at. Again, 0. So we're taking a look at the very first, and we're not looking at size. So we're looking at the first byte and nothing else. And what we're going to do is we're going to do the AND operator with this. Now you're probably wondering, what in the world is that? So that is a hexadecimal number, right? So it's the hexadecimal number F. And that has an equivalent in binary that looks like this. And so what we're doing with that is we're doing the AND operator. Again, very similar to the previous example. And if that AND operator with that, hexadecimal number in that first byte, if that does not equal 5, then we'll capture it, right? So that's what that is. And it says right here, it will return true if the result is not equal to the decimal number 5, or this binary. And again, it's pretty tricky because we're using binary. So don't worry too much if those examples didn't make sense. You'll learn more about it if you keep going through cybersecurity stuff and TryHackMe. So now they get down to some of the stuff that we're going to be using that will help us out a bit more in this room. And we're going to do TCP and TCP flags. So what this does is this just refers directly to the flag field in a packet. And so we can look at TCP SID for synchronize, ACK for acknowledge, FIN for finish, and RST for reset, and push for push. So these are the different types of flags, and we can filter based on the flag. And they give us some examples here. So Tcpdump, and then we're filtering by TCP flags, and we want that to be equal to TCP SYN. So we will capture packets where only, that's important here, only the SYN flag is set, right? Because we want the flags to equal just this, nothing else, okay? Then down here, we have similar example again, Tcpdump, we're looking at flags, and we want TCP SYN to not equal 0. So what this does is this is going to capture all the TCP packets with at least the SYN flag set. Why at least? Because we know it's not equal to 0, which means it can be any other number. So we may have other flags on the packet, or maybe we don't. It doesn't really matter. As long as there is at least one, as long as the SYN flag is set, then it will pick it up. And then down here at the bottom, what we have is we have this AND, so it'll be TCP SYN, or, because remember, this is our OR operator when we're talking about bits and when we're talking about this type of filtering. Or TCP ACK does not equal 0. So this will capture any TCP packet where the SYN or the ACK flag is set. Because again, we're doing this not equal to 0 thing. So that's important to keep in mind, and we'll be referencing these as we answer the questions. So now down to the questions. How many packets have only the TCP reset flag set? Okay. So the way that we would do this, first let me clear this. And so we'll do Tcpdump, right? And then we'll take a look at kind of our format. So they want TCP flags. So what I'm going to do is, I'm lazy, so I'm just going to copy this. And then I'm going to paste it. And so, but you can't just mindlessly paste. You got to understand what's going on. So this is for only the SYN flag set. We don't want that. We want only the reset flag set. So what is that? That's TCP-RST. So let's get in there and change this to RST and see what we have. Okay, made a silly error here. So we don't have permission to capture on this device. what we're trying to do here is capture. We don't want to capture though. We want to read from our file, right? And our file is that traffic.pcap because that's what we're using to answer all the questions. So I forgot to include that. So be smarter than me. Okay, so that's quite a bit. So I don't want to count all those. So again, if we don't want to count everything, we can just pipe it into WC. And again, I'm just hitting the up arrow to go back to previous commands. And then we can see we have 57. So the answer to this should be 57 packets. And that's the right answer. Now, this question, what is the IP address of the host that sent packets larger than 15,000 bytes? Okay. So if I remember right, we'll come up here. We don't need any of this. And we're going to say greater. I think we can just do the number 15,000. Was it 15,000 or 15? Yeah, 15,000. So that's what I think it is. Let me double check. Yep, greater followed by the length. So pretty straightforward. So let's run that. And now what do they want to know again? They want to know what is the IP address of the host that sent packets larger than 15,000 bytes. So it sounds like only one host was sending packets larger than 15,000 bytes. Now again, if we look at this, I did not do the -n. So if I copy and paste one of these IP addresses, TryHackMe is going to tell me that I'm wrong. So I'm going to do -n on the end of this. There we go. That makes it easier. So which host is sending? And that would be this guy. And again, because I'm doing this -n, you'll see this is the port number. So don't get confused. Some of you might come down here and just highlight this whole thing or try and highlight this. But again, if you pay attention, that's too many numbers for an IP address. This is the IP address. And then that 80 is just the port number. Okay. And then same thing here. This IP address just goes all the way to here. And then this is the port number. So keep that in mind. And then we'll just paste what we have. Oh, nope. I accidentally highlighted that when I was explaining something. So let's go back, highlight that, and now we'll paste that IP address, get rid of that last dot, and that's the right answer. So with that, we are done with task 4. Now it's on to task 5, displaying packets. Okay, so now we've talked about filtering. So now we're going to mess with how they actually appear when we display them. So let's say we filtered our packets, we have the packets we want. Now what information do we want to see about that actual packet? So here we have a few options. We can display using -q, which will just give us a quick print of packet information. That's what the Q stands for, quick. -e, which will print the link level header. So what does that mean? Link level, if you're understand the OSI model and you have a decent networking base to work with, then you should be thinking MAC addresses, okay? And then A is going to show packet data in ASCII, and then XX is going to show packet data in hexadecimal, and then X is going to show packet header and data in hex and ASCII. So we'll look at that. They have examples for us. So here they're just using this toPacket.pcap. They use -q. And if you use -q, look at how streamlined this is. Just IP address and then you get the port, where it's coming from, where it's going. Really quick, hence -q. Then we have the link level header. And what this will do, again, like I said, this is really going to help us by displaying MAC addresses. So we can see all the MAC addresses here, right? So this MAC address is sending something to this MAC address. And then it includes all this additional information down here. But yeah, so that's what's included when you do -e. And basically what it's doing is it's giving you the link level header stuff. But really, for the most part, when we're using this, we're going to be looking at MAC addresses. That's what we want to know. Unless you get deep into the link layer and know more about it. I do not. So I use this when I'm looking at MAC addresses. And then we have display packets in ASCII-A. So basically, ASCII code represents text. So when you use -A, what you're doing is any byte that is equivalent to ASCII, like in English letter, number, or symbol, it's going to show that. And so that's what this looks like here. So this is the actual ASCII. All of this with the dots and then the occasional symbol or number or letter, right? So we can see that for both of these two packets. Now, in this example, this information isn't super useful, but sometimes you can find strings and you can find useful information inside of this. It just depends. So that's what the -A is going to do. Then we have -XX, and this is going to give us the hexadecimal of everything. Okay, and if you don't know a lot about hexadecimal, don't worry, you'll learn about it more as you go through TryHackMe, but each hexadecimal digit is 4 bits. And so this is like, another way to look at this is like, this is the hexadecimal instead of us getting the binary of what's actually being passed back and forth, because each hexadecimal digit represents 4 bits. So that's what the -XX does. And then this is really useful. This is your -big X option. And what that's going to do is this is going to give you the hexadecimal along with the ASCII. Okay, and this can be useful as you learn more about packets, about hexadecimal, and files and stuff like that. As those are getting transferred, you'll be able to note things inside either the hexadecimal or the ASCII, or sometimes both, and be able to identify parts of a packet just by looking at this, and that can be very useful. So that's what all those display options do. Here's a summary. And then down to the question, what is the MAC address of the host that sent an ARP request? Okay, so if I remember right, there was not a whole lot of ARP traffic, so we should just be able to do ARP, but then we want to display it a specific way. And what we want to do is we want to know the MAC address of the host that sent the ARP request. So an easy way to do that, or at least in this example, they want us to do -E to include that MAC address. Now, do we have to do that? Technically, we don't, because we can tell based on the conversation. Oh no, wait a minute. Actually, we do. I was wrong. Here's one of the MAC addresses is at... Okay, yeah, so if we want both of them, if we want to know who's sending it, we do have to use -E. So if we use that -E to include, then what we can do is we can see this, here's that MAC address, is sending out the broadcast, and it's asking, hey, who has this IP address? So this is the MAC address that's asking. So they're the one who sent the ARP request, so let's submit that. And that's the correct answer, and with that, we are done with task number 5. Now it's on to task number 6, the conclusion. Basically, Tcpdump, super useful, and as you learn more about Wireshark, T-Shark, all that stuff, it's just going to help you understand networking and packets, and it's all good stuff. So congrats on finishing the room. I hope you found this helpful. If you did, give it a like and subscribe. That helps me out a lot. And with that, you have finished the Tcpdump The Basics room from TryHackMe.